Hello students, welcome back to today's class on lines and angles, and in that we are going to discuss some properties of a triangle. We are discussing lines, we are discussing angles, and using all those we are trying to discuss some properties behind triangle. And in the last class also we have discussed a couple of angles. Once again, let's see all those and then we'll move forward to for today's concept, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So in the last class, we had discussed something about lines and transversal, and we have discussed some angles there. Okay, let's try to discuss a couple of more things that we are left over. Okay, which is started here. Lines which are parallel to the same line are parallel to each other. So if we have one line, and let's say I say A is parallel to B and B is parallel to C. Okay, I can say B is parallel to A and B is parallel to C. Okay, these two lines are parallel to the same line B. From there, I can say that all the lines are parallel. Parallel means on the same orientation, same same direction. Okay, it's not that this is one line and this one line. No, these two are not parallel. These two will definitely intersect at some point. The non-intersecting lines are called parallel lines. Right? So how can we prove whether the lines are parallel or not? So for that we discussed different theorems yesterday, all with parallel lines, with all the different angles. Okay, we can use all those relations. How to prove two lines are parallel? Showing a pair of corresponding angles are equal. I said you, when a transversal is going through two parallel lines, corresponding angles are equal. So in the reverse way, if you can show that corresponding angles are equal, you can say that both the lines are parallel. And here, pair of alternate interior angles are equal. If these two are equal, then also we can say that the lines are parallel. Or pair of interior angles on the same side. Don't get confused. Interior angles on the same side are supplementary. We have discussed all this in the last class, right? So you can use all those theorems or all those properties to show that the lines are parallel, showing both the lines are perpendicular to the same line. What is the symbol? This symbol, okay, this is called perpendicular. What do you mean by perpendicular? If there is a line like this, okay, and this one more line where the angle between these two is 90 degrees, we can say these two lines are perpendicular. Okay, showing both lines are perpendicular to the same line. So if I take one more line, which is again perpendicular to this line, I can say that these two are parallel. Okay, this 90 degrees, you can treat this as a transversal, and these two are two different angles. You can name them according to the properties, and if those two are equal, which are on the same side of the transversal, we can say that they are parallel. Okay, showing both lines are parallel to the third line, the point which we have discussed just now. First line, second line, and there is one more line which is parallel to the second line, so we can say that all these lines are parallel. Right? Let's try to discuss one or two questions based on all the properties we have discussed till now. In the given figure, AB is parallel to CD. Okay. CD is parallel to EF, so this line is again parallel to this line. So I can directly say that all the lines are parallel. Okay, and Y is to Z is 3:7. Y is to Z. Carefully see here. These two are on opposite side. One is exterior, one is interior for this reason. Okay, so based on all these properties which I have discussed in last class, whether they are on the same side of the transversal or opposite side, whether they are equal or supplementary, right? So all these properties we are going to bring it now to get the values of x, y, and z. In the given figure, we need to find x. Where is x? Here. Okay, so now let's try to discuss about y and z. What will happen with y and z? For example, I'll take one more angle. Okay, one more angle. If this is z, I'll take one more angle here. Okay, let's say this is some t. This angle is some t. What relation I can bring between t and z? On the same side? On the same side of the transversal? On the same side of the transversal? One is interior, one is exterior. One is interior, one is exterior. Alternate. Alternate. Correct? One is interior, one is exterior. So I can say that these two angles are equal. These two angles are equal. We can say that angle T is equal to angle Z. One more thing we have discussed in the previous classes, straight angle. You can see Y and T are straight angles. Correct? Y and T are straight angles. So angle Y plus angle T is equal to 180 degrees. Angle Y plus angle T is equal to 180 degrees. So what I can say now about angle T is equal to 180 minus Y. Angle T is equal to 180 minus angle Y, correct? Okay, or you can just remove all the angle symbols just for clarity. Okay, but now there is some relation between Y and Z we need to talk about. There is a relation between Y and Z. Although we got some relations between Y and Z, okay, Y is to Z is equal to 3 is to 7. We'll try to use these two properties because here T is Z, correct? So Z is equal to 180 minus Y. So I'm taking Y as some 3T, okay, or you can say Y plus Z is equal to 180. That is the relation I want to bring. Okay, simply T is equal to Z. You can directly substitute there without all this confusion. Okay, see here. Once again, I'll tell you that Y plus T is 180 and we know that T is equal to Z. These two are equal. So this T is also equal to Z. So I can say that Y plus Z is 180 degrees. Y plus Z is equal to 180 degrees, right? Simply these two are opposite side of the transversal. One is exterior, one is interior, right? Using that property also we can say that these two are supplementary. Y plus Z is 180 and let's take Y is equal to some 3 times of P, Z is equal to some 7 times of P. Okay, so because they are in the ratio, so using this information we can try to bring about Y plus Z. Y is 3P plus Z is 7P. 3P plus 7P is equal to 180. 10P is equal to 180 and P is equal to 180 by 10. 180 by 10 which is 18 degrees. That is the value of P. So using that we can try to find what is Y. Y is equal to 3 times of 18 which is 54. Which is a 54. And Z is equal to 7 times of 18. What is 7 times of 18? What is 7 times of 18? 18 7s, 8 7s, 56 and 1 7 and 126. Is that correct? It is it's 54, right? Sorry. 3 into 18 is 54 and 7 into 18 is 126. You can see, you can carefully check. These two will sum up to give you 180 degrees. These two will sum up to give you 180 degrees, Y plus Z. So we have Y which is 54 and Z which is a 180. Sorry, Z which is a 126. Okay, so now we need to bring again some relation between X and Y. Between X and Y, because these are the angles on the same side of transversal, both are interior. Same side, both are interior, co-interior angles if you can see, which are supplementary. These two are co-interior, which are supplementary, right? So X plus Y is equal to 180. X plus Y is equal to 180. X plus Y equal to 180. So X plus Y is 54 is equal to 180. So X is equal to 180 minus 54, which is a 126. So even X is equal to 126, right? So that is how you can try to find the relation between all these angles. Okay, so I'll give you one more question behind this one, same concept, so that you can try. Okay, but you need to understand which is transversal for what, which is a very interesting question. I want you to try this one. Okay, in the given figure, OA is parallel to CD. OA is parallel to CD. Find the value of X. So this one parallel line, this one parallel line. You can take wherever required this as one transversal, and you can also take this as another transversal. So transversal, right? So there are different angles you can try to understand, or try to bring some relation between A and X and 130, and you can try to bring between the values of all this, right? So this one you can try, a very beautiful question. Let's move for the next concept. Okay, we have one more question. Yeah, PQ is parallel to RS. We have a PQ parallel to RS. Okay, these two lines are parallel, and it was given angle MXQ. MXQ is 135 degrees, 135 degrees, and angle MYR is 40 degrees. Okay, 135 and 40. So using that information, try to find angle XMY. So you need to find this angle, right? So please try to apply all the concepts which you have learned, and you can simply do that. So please try that. It's a very interesting question. The next one we're going to discuss about triangles, okay, which is the first property behind the triangles, which is today's lecture. The sum of interior angles of a triangle is 180 degrees. Sum of interior. What do you mean by interior? On the same side. Interior means on the same side of some two lines, whatever it is. Interior means inside. Inside, okay, not on the same side. Interior means inside the triangle. Okay, so let's try to take a triangle. Let us name that ABC. Let us name that ABC. Okay, sum of the interior angles of a triangle is 180 degrees. So let me write that this is one angle X, this is one angle Y, and this one angle Z. So the property here is all the angles will add up to give you 180 degrees. Okay, so angle X plus Y plus Z is equal to 180 degrees, and there are simple applications behind that. Okay, I'll give you this angle as 20 degrees, this angle as 50 degrees. So what is the other angle? Okay, if this 20, 50, 70, you can try to find the other angle. So based on that, you can have different types of questions. When two angles are given, we can try to bring the third angle, because the sum of all the angles is 180 degrees. And based on that, we can say acute angles, obtuse angles, right angle triangle. Right angle means 90 degrees. One of the angles should be 90 degrees. Obtuse means one of the angles should be greater than 180. Okay, greater than 90. So that's the first property behind the triangles, which is angle sum property. The value of the angles of triangle are 2x, 3x plus 5 and 4x minus 14. Find the value of x and the measure of each angle of the triangle. A simple question, very beautiful simple question. What is that? Angles of triangle are, the first one is 2x, the other one is 3x plus 5, and the other angle is 4x minus 14. So what we just discussed before this slide, that the sum of all the interior angles is 180 degrees, correct? Sum of all the interior angles is 180 degrees. So add all this, 2x plus 3x plus 5 plus 4x minus 14 is equal to 180 degrees. 2x plus 3x plus 5 plus 4x minus 14 is 180 degrees. 2 plus 3 is 5, 5 plus 4 is 9. 2 plus 3 is 5, 5 plus 4 is 9. 9x, 5 minus 14 is minus 9. 5 minus 14 is minus 9. 5 plus 4 is 9x, 5 minus 14 is minus 9, is equal to 180. So you will get 9x equal to 180 plus 9, which is 189. So x you will get it as 189 by 9. Okay, so which is 9 1s, 9 2s are 18, and this 1. So x will get it as 21 degrees. X is 21. Find the value of x and measure of each angle. And measure of each angle, that means we need to find all the angles, not just the value of x. So 2x, 2 into 21, which is a 42. 2 into 21, which is a 42. 3x, 3 times of 21 plus 5, 63. 63 plus 5, 21 plus 3 is 63. 21 into 3 is 63. 63 plus 5 is 68. 63 plus 5 is 68. Okay, 4x minus 14. 4x minus 14, 4 times of 21 minus 14. This is 84 minus 14, which will give you 70 degrees. Let me check. All the sum of all the angles should be 180 degrees. Is that correct or wrong? First angle is 42. The second angle is 68 and the next angle is 70. Let us name that ABC. Okay, we didn't name that. Triangle ABC. So 8 plus 2 is 10, 4 plus 1 5, 5 plus 6 11, 11 plus 7 is 18. Yes, sum of all the angles is 180. So you can verify in this method to get a confirmation that you have done correct. Whatever you have done is correct. So what are the different angles? One is 42 degrees, one is 68 degrees, and the other is 70 degrees. Correct? Let's move forward to the next question. If side of a triangle is produced, we are going to discuss about exterior angle in a triangle. You can see here, this is a triangle and one side is being extended. So we are getting a new angle here, which is exterior to the triangle, right? If a side of a triangle is produced means it is elongated, extended, then the exterior angle so formed is equal to the sum of the two interior opposite angles. That means, if we say this is angle X, this is angle Y, this is angle Z, and let's say exterior angle, let us say some U. That exterior I am taking as U. Okay, in triangle ABC, side BC is extended to get one exterior angle U. This angle U is equal to sum of two interior opposite. See, this is not the angle. This is not opposite to this one. U and Y are not opposite. They're side by side, adjacent. But this is equal to the sum of X and Z. This is equal to sum of X plus Z. How to get that? Very easy. These two are forming a linear pair, correct? So I can say that linear pair in the sense of straight angle. Okay, straight angle. U plus Y is equal to 180 degrees because it's a straight angle. U plus V is equal to 180 degrees, straight line. And sum of all the angles is 180. X plus Y plus Z is equal to 180. So it is enough to, if you subtract these two or if you substitute one with the other. Okay, so when you subtract these two or when you try to add, so subtracting, all these subtracting from the first equation, Y and Y gets cancelled. So U minus X minus Y is equal to 0. So U is equal to X plus Y. Okay, or just try to substitute Y from here and substitute here and we'll get the answer. Right, so that is about exterior angle property. Let's discuss one more. So we have a question here, find the value of X in the given figure. Exterior, so see which angle is exterior here. X is the exterior. I'm sorry. X is exterior, which should be equal to the sum of opposite two interior angles. So X is equal to 50 plus 60. X is equal to 110. Or you can also bring the same approach in another way, which I will tell you. 50 plus 60 is 110. Sum of all the angles is 180. So this angle should be 70 degrees. Because sum of all things is 180. If this is 70, again these two will form a straight angle whose sum should be again 180. So 180 minus 70, which will give you 110. 180 minus 70 you can get as 110. Using that also you can try to proceed. Both the same. Whichever approach you do, the last final answer should be same, which is a 110 here. Right. Let's move forward for the next question. Find the values of X and Y in the given figure. Okay, we have a question here. Carefully see here. There is a triangle which is extended on both the sides. There is a side which is extended here as well as in that direction also. Okay. Find the values of X and Y in the given figure. So let us try to see that, how to do that. Okay. I have some information here because this is complete straight angle. As this is 140, y will be equal to 180 minus 140, because this complete thing should be 180. This complete thing should be 180. Correct? So y is equal to 40 degrees. Y is equal to 40. Now, using exterior angle property which we discussed just now, angle x should be equal to 30 plus 40. Angle x is equal to 30 plus 40, which is 70. So angle x is equal to 70 degrees. And what about this angle? 30 plus 40 is 70. So 70, this should be 110. This is not asked, but still, if the question is asked about angle ABC. Angle ABC, that means we are talking about angle B. ABC is angle B, which is again 110. Okay, we should not write 70. Okay, that is how you can try to relate different angle properties, angle theorems, lines and transversal theorems, and you can try to bring different relations among the angles, and you can try to find all the unknown things. Okay, so one more question, find the value of x in the given figure. So what is this again? Okay, again there is an, now carefully see here, here we are not having one exterior, we have two exteriors on two different sides. Okay, if we name this as ABC, here BC is one extended and as well as AB is also extended, right? So let's try to bring properties or values slowly from here. 110, so this angle should be 70 degrees because these two sum should be 180, right? And this exterior 135 should be equal to sum of these two. Simple, it's done. This is 130, it should be 135, which should be equal to sum of these two. So 135 should be equal to 70 plus x. So x is equal to 135 minus 70, so which is a 65. The value of x is a 65. What about this angle A? It is a 135 minus 180 minus 135. Just now, just in case if you want to find this one, okay, which is 180 minus 135, which is a 45. Okay, so this angle is 45. 45, let us check all the angles should be equal to 180, 45, 65 and 70, 65 and 70, 10, 8 and 10, yes, 18. So sum of all the angles is 180. Sum of all the angles is 180, right? So this is how you can try to understand and apply all the angle properties, line properties, transversal, and all the triangle properties, right? So I hope you understood all these lectures on lines and angles are very beautiful. Very interesting topic. In the coming days, we're going to discuss more applications and more concepts like this, right? Thank you so much, friends. Stay tuned to get the next lecture. Thank you.
Yeah. Hello everyone. So today we'll be going into the practice of equations of motion. Okay. So my name is Shashin Reddy. I'm a graduate from IIT&NEET. Let's go into the class. So usually, most of the times we have this confusion. What is the confusion? That which equation to use, right? We have different equations. We have equation V is equal to U plus AT. We have the equation S is equal to UT plus half AT square. And we have the equation V square is equal to U square plus 2AS. We have all these three equations, but the basic question is, if I come across a numerical, then which equation should I use? Should I use V is equal to U plus AT? Should I use S is equal to UT plus half AT square? Or V square is equal to U square plus 2AS? That's what we'll try to understand in today's class. Okay? Okay. So there are some simple rules that we have to follow. When we follow that, any numerical, not only here, not only equations of motion, anywhere will become very simple. Okay, what is that? The first one is this. When you read a question, when a question is given to you, first thing you have to do is read it, understand it, and write down the given information. Do not skip that step, okay? The steps are there for a reason. Do not skip any step. Write down the given information and make sure that the acceleration is constant. Now this condition is specifically for equations of motion because equations of motion are applicable when acceleration is constant. So that is the reason. So write down the given information and make sure that the acceleration is constant. Then figure out which quantity is to be found. I mean, you might have to find initial velocity, final velocity, or displacement, or acceleration, or time. Whatever it is, write it down. This is the given information. This is what we have to find. Now when you have these two, then you can select the proper equation. Then apply the proper equation considering the quantity is given. Now that is the question, right? How do we do it? If you follow these steps, the third step will become easy. I have a simple example for that. Look at this. Let's say there is a question in which this is the given information. What do you have? We have final velocity, initial velocity, acceleration. We have those three. And let's say displacement S is to be found. Now which equation should I use? Okay, so you can go with all the three equations. You can take them down one by one. So let's say I have to find out V is equal, I'll take the equation V is equal to U plus AT. And what should I find out? Displacement S is to be found. Now if you find out S, if you want to find out S, then S should be in the equation, should be in the formula. Do you have S here? Do you have S in this formula? No, that means we cannot use this equation to find out S. Done. Then I'll go with the second equation. What is second equation? S is equal to ut plus half at square. The first thing that you have to do is check whether you have S. Is there S in this equation? Yes, we have S. Do we know S? We don't know S. S is an unknown quantity. We have to find out S. Now look at the other things. Do you have U in the given information? U is there. U is there. Good enough. Do you have time in the given information? Do you have it? Time? No. So time is also not there. So what I do is I circle when I don't know them. So you have two things which you don't know. You don't know S, you don't know T. You don't know S, you don't know T. So when there are two things that you don't know, you cannot use this equation also. Thing is, if you want to find out S, except for S, you have to know everything else. If time is given, you can use this equation, but time is not given. So we cannot use this equation directly. Directly we cannot. Then what about the other equation? The other equation is V square is equal to U square plus 2AS. Can I use this? Let me verify. What we have to find out? S. Do we have S? We have. Do you know S? We don't. But apart from S, do we have everything else? Do you have V? See, we have V. V is given as 10 meter per second. So we have V. So I can cross V. Do you have U? Yes, you have U. Do you have A? Yes, you have A. That means when you look at this equation here, we need to find out S. We don't know S, I am circling it. But except for S, V, U and A, all three of them are given. That means I can easily use this equation directly. If I use that equation, I'll get S. Okay, let's try finding it out. We have V square is equal to U square plus 2AS. V is given as 10, U is given as 5, A is given as 10. So I'll use it. V is given as 10, so 10 square. U is 5, 5 square. Plus 2 into A is given as 10, and you have to find out S. 2AS. In place of A, you have 10. S, I'll leave it as S itself. You just substitute. You write down the formula, substitute. Then solve. What is 10 square? 10 square is 100. What is 5 square? 25. 2 into 10 is 20. 20S. I'll exchange. So it is 25 plus 20S is equal to 100. Then we'll take 25 to the other side. It becomes 20S is equal to 100 minus 25. What is 100 minus 25? 75. Then comes the next part. This 20 you will take to the other side. 20 here is multiplication. If you take it there, it becomes division. S is equal to 75 by 20. That's it. That is the answer. It is 37.5, I think 3.75. S displacement, the units are meters, SI units, because everything is in SI units. Now the only thing is you have to be careful about the calculation. Okay, you have to be careful that the calculation doesn't go wrong. You have to be very careful about that, and nothing is gone wrong, everything is correct. That's it. Simple, right? That's how simple it is. The three rules that you have to follow, the three steps that you have to follow is, first one is what? Write down the given information. Second, figure out which quantity is to be found. Third, apply the proper equation. I told you how to apply the proper equation also. Whatever you have to find out should be the only unknown quantity. I mean, if you want to find out S, except for S, everything else should be given. If I want to find out time, except for T, everything else should be given. Okay, so we'll go into a few problems, a few numericals, a few questions, practice questions, so that you will understand things clearly. Okay? Okay. So the first question is here. Now it's a very simple one. Let's look at this. A racing car has a uniform constant acceleration. A uniform acceleration of 4 meters per second square. What distance will it cover in 10 seconds after start? 10 seconds after start. Now this is important. So here what all information do we have? I'll write down the given information, the first step. We have acceleration which is constant 4 meters per second square. We have to find out distance or displacement. Time is given as 10 seconds. And they are saying that after start, at the beginning, at the starting of the race, what will the speed of the car be? 0. Right, so U is equal to 0. So you have three quantities: acceleration, time and initial velocity. What we have to find out is what distance. Now in these questions normally, or wherever acceleration is constant, then what happens is distance and displacement will be equal. Because even if it is not clearly mentioned, we'll go with the assumption that the motion is along a straight line. And we know when the path is a straight line without change in direction, distance will be equal to displacement. So here we have to find out displacement. If you get displacement, you will get distance. This is the given information. Now which equation can we use? Let's go with all of them. Let's see whether this equation V is equal to U plus AT can be used or not. See here what we have to find out. We have to find out displacement. So do you have displacement here? Do you have S? Do you have an S here? We don't have S. That means I cannot use that equation. Right? Then let's look at second equation. S is equal to UT plus half AT square. Now let's verify whether we can use this. We have to find out S. So S is here, we have to find it out. So okay. Now apart from S, do we have everything else? Do you have U? U is given 0. Do you have time? Yes. Do you have acceleration? Yes. Do you have time? Yes. So apart from displacement, which we have to find out, we have everything else. So if I use this equation, I'll substitute them, I'll directly get the answer. Let's try finding it out. This is the given information. I'll again write it down. What was given? Acceleration is given as 4 meters per second square. Time is given as 10 seconds. U is given as 0. Then which equation can we use? S is equal to UT plus half AT square. We have to substitute, so let's substitute. S is equal to, what is U? U is 0. So 0 into 10, time is 10. But 0 into 10, we know what it is, 0. It is 0. Plus half into, what is acceleration? Acceleration is 4. Then you have to be careful with the term t square, because generally students make this mistake. That is the reason. When you say t square, square is what? Twice. So t into t, you have to multiply twice. Time is 10 seconds. You have to take 10 square. So 10 into 10. It is 10 into 10. Now look at this. 2 and 4. 2 2s are 4. So what's remaining here? 0 into 10 is 0. Plus here 2 is remaining. 10 into 10 100. So 2 into 100 200. 0 plus 200 is 200 meters. So displacement is 200 meters. See, very simple. All the steps are given here. Given information, formula, substitute, solve. Given information, formula, substitute, you will get the answer. Trust me, the more number of questions you practice, the easier it becomes for you to select the correct equation. Every time you need not actually write it in this way. Once you practice enough number of questions, you will become habituated. You will get comfortable, and you can directly select the equation that you have to use. I can directly do it now. Okay, you need not practice much, some number of questions. Okay, so the beginning will be difficult, but later on it becomes easier. So do not forget to practice. Even if it is difficult, keep practicing, because only with practice you become better. Okay, by the way, the correct answer is 200 meters. We got it. Clear? Yes? Okay, let's go into another question. Now this question is interesting. A ball is thrown upwards. So you have to imagine. Throw a ball up. A ball is going up. Imagine. A ball is thrown upwards with a speed of 20 meters per second. And a downward acceleration of 10 meters per second square acts on the ball. What is the maximum height reached by the ball? Now let's try to understand this. Understand the case. We'll write down the given information, but the first step is understanding the question. Let's say you have a ball here. Now we are throwing the ball up. With what velocity or with what speed? With a speed of 20 meters per second. That is, at the bottom the speed is 20 meters per second. Now generally when you throw a ball up, what happens to its speed? Will it increase or decrease? Huh? As you throw a ball up, its speed decreases, because you know, right? The ball goes to some height, stops and comes down. So forget about coming down. While it is going up, its speed decreases and becomes zero. Right, so here S is equal to, at the bottom the speed is 20 meters per second. As you throw a ball up, what happens to its speed? 20 becomes 19, then 18, then 17, then 15, 14, 10, 5. I mean, in between there are other values also. I'm skipping it. 10, 5, 4, 3, 2, 1, 0. Right, so here the speed keeps on decreasing, and at the final point, at the topmost point, V is equal to 0. At the highest point, what happens? The ball stops. Speed becomes 0. Yes? So, you have it. And what is clearly mentioned here? A downward acceleration of 10 meters per second square. So here we can clearly see that velocity is upwards. As the ball is going up, the velocity will be up, but acceleration is downwards. And here we can say speed is decreasing. So that means here we have a case of retardation. So you have to take acceleration as minus 10 meters per second square. Why? Because speed is decreasing, velocity is decreasing, it is negative acceleration. Now all this we understand from what? From the question. So I have drawn it, and the figure itself we have the given information. At the bottom you have initial velocity u, acceleration is negative, and the final velocity is 0. So if I write down the given information here, given u is equal to 20 meters per second, final velocity is equal to 0, and acceleration is, do not forget the sign, minus 10 meters per second square. So acceleration is minus 10 meters per second square. Do not forget the negative sign. Very, very, very important. Now what we have to find out here, we'll again come back to the question. What is the maximum height reached by the ball? Now how do you understand the maximum height? What is the maximum height? From the ground, look at this. The maximum height is this, yes or no? The topmost point is this point, wherever the speed is 0. So topmost point will mean height is maximum. So this is the height that we need. And look at that. The beauty here is this distance. This is the distance traveled, or this is nothing but in this case displacement. So from the bottom point to the topmost point, that is the displacement, and that displacement is equal to height. Yes or no? See, these both are equal. So here the maximum height that we have to find out, if we find out at h max, that is equal to displacement, and that's what we have to find out. We have to find out displacement. You have u, v, a, and you have to find out displacement. Which equation to use? Let us take third equation. Let's see whether this is the equation we have to use or not. We have to find out s. Do you have s? Yes, do we have it? I mean, that is in the equation. Apart from s, let's look at the other quantities. Do you have v? V is equal to 0. Yes, we have v. Do you have u? U is given 20. Good. Do you have a? A is also given -10. So we have everything else except for s. So we can use this equation. This v square is equal to u square plus 2as. I'll just rearrange it now itself. If I take u square to this side, it becomes v square is equal to, for v square minus u square is equal to 2as. Just rearrange 2as is equal to v square minus u square, interchange. Then I need s, so I'll take 2a to that side. S is equal to v square minus u square by 2a. Now you can also remember this formula, which is nothing but another way of writing down v square is equal to u square plus 2as. It will directly help you in problems. Better than rearranging, you can use this directly. That is the reason. So if I use that, which is s is equal to v square minus u square by 2a. You have to substitute and be very careful while you substitute. What is v here? V is 0. So 0 square, which is 0 by the way. 0 into 0 is 0. U is 20 and you have to take 20 square. Do not forget the minus sign. It is minus here. Minus 20 square upon 2 into acceleration. What is acceleration? Acceleration is negative. So whenever you have negative, take brackets so that you will have no confusion. I'm using brackets here so that there will be no confusion. Which is equal to 0 square is 0 minus 20 square. 20 square is 20 into 20, which is how much? 400 upon 2 into minus 10. Negative will be there, minus 20. Now here look at this, 0 minus 400 minus 400 by minus 20. Now you will realize the importance of negative sign. You had to take acceleration as negative so that they will get cancelled. And here 0, 0 cancel. Then 40 by 2. What is 40 by 2? 40 by 2 is 20. So here it is 20. So S is equal to 20 meters. That's it. So these are the steps again. As I told you, given information, what you have to find out, formula, substitute and solve. Simple, right? Yes? Okay, that's good. Let's go into this question. Now this is mostly a theoretical type of question. Let me explain that. If the displacement of an object is proportional to square of time, then the object moves with, you have options, uniform velocity, uniform acceleration, increasing acceleration and decreasing acceleration. What is that? Let us solve it to find it out. Okay, let me just do it in this way. Let me explain it. This is something you have to listen to me. Theoretical. So S is equal to ut plus half at square. S is equal to ut plus half at square, right? Now here, let's say, if u is equal to 0, possible, initial velocity can be 0. It is also a special case. So if u is equal to 0, then what happens? 0 into t, u is 0, so 0 into t plus half at square. 0 into anything is 0. 0 plus anything is that anything. So I can directly neglect this and say S is equal to half at square. Now if you look at this, this is the equation we need, because in this equation, S is directly depending on t square. Do you know how we write this down? We write it as S is directly proportional to t square. What is that? S is, I'll even write down the statement, S displacement is directly proportional to square of time. That's how you write it down. That's what it means. Read the question once. If the displacement of an object is proportional to square of time, that's what we have here, directly proportional to square of time. Yes. What is that? Then the object is moving with. Now you tell me the option. Uniform velocity, uniform acceleration, increasing acceleration, decreasing acceleration. What do you think it is? It is uniform acceleration. Yes, because this equation is valid only when acceleration is constant. Only if acceleration is constant. That is the reason why it is uniform acceleration. This complete equation, whatever we are doing is valid, is applicable only when acceleration is constant. So this condition that we got here, that is displacement is directly proportional to the square of time, is applicable, is true, is valid only when acceleration is constant. And that means uniform acceleration. Uniform will mean constant. Simple. Understood? Okay, good enough. Next question. A uniformly accelerated car covers 30 meters along a straight line in 2 seconds. A uniformly accelerated car covers 30 meters along a straight line in 2 seconds. What is its acceleration? We have to find out acceleration if it has started from rest. Now we'll do it in separate ways, because you have case A and case B. So let's go into case A first. Just a minute. Or else, yeah, case A. So here read the question. Uniformly accelerated, that means acceleration is constant. So we can use the equations of motion. Covers 30 meters. I told you in uniformly accelerated cases, distance is equal to displacement. So it covers 30 meters, so displacement is 30 meters. Along a straight line, it is clearly mentioned, a straight line, in 2 seconds. So time is 2 seconds. Now, what is its acceleration? You have to find out acceleration. If it has started from rest, it has started from rest, that means at the beginning or its initial velocity is what? 0. Started from rest. Rest will mean the speed is 0. So here the initial velocity is 0. So you have S, you have T, you have U, and you have to find out A. Can we do it? Which equation do we use? Let's try using second equation. S is equal to ut plus half at square. Let's verify whether we can use this. We have to find out acceleration. Yes, we don't know acceleration. We will find it out. But apart from acceleration, do we have everything else? Do you have S? Yes. Do you have U? Yes. Do you have time? Yes. That means except for acceleration, we have everything else. So we can use this equation. S is equal to ut plus half at square. There's one more interesting thing, I'll tell it to you now. Here u is given as 0. So when u is given as 0, this complete term ut, it becomes 0. So I can directly say as u is equal to 0, I can just neglect that term. I can say s is equal to half at square. This formula reduces to s is equal to half at square. It becomes very simple. Okay, can we use that directly now? We can use it. So s is equal to half at square. We have to find out acceleration, but let us substitute. S is 30 is equal to half into acceleration, we don't know, and time is 2 seconds, but I told you it is t square, so 2 into 2. Then you can clearly see here 2 and 2 cancels. What will remain? 30 is equal to 2 into a, 2a. This 2 goes to the other side, becomes 30 by 2 is equal to a, 15, or a is equal to 15 meter per second square. 15 meter per second square. See, we got the acceleration. Simple. Yes? Okay. That's good. Now I'll go into the second case. Case B. Now case A and case B are similar. The only thing is, case B, it was initially moving with a speed of 7.5 meter per second. That means the initial velocity is different. Everything else is the same. Okay. That means if I write down the given information, s is the same, time is the same. S is equal to 30 meters. Time is equal to 2 seconds. U is given as 7.5 meter per second. That is the change. And again we have to find out acceleration. Similar question, the same equation can be used. S is equal to ut plus half at square can be used. Yes, so s is 30, u is 7.5. Let us substitute. Into what is time? Time is 2 plus half into, we have to find out acceleration, into t square. What is t? 2 square. We have to be careful. 2 into 2. Then will anything get cancelled here? Let's say this half, this 2 and 2 gets cancelled. Yes. Then you have here 30 is equal to 7.5 into 2. What is 7.5 into 2? 15. Yes. Plus a into 2, 2a. Then 15 comes to this side, it becomes 30 minus 15 is equal to 2a. 30 minus 15 is 15, 15 is equal to 2a. Right, or 2a is equal to 15. 2 goes to that side, you get what? You get a is equal to 15 by 2. 15 by 2 is 7.5 meter per second square. See? In this case we get 7.5 meter per second square, but in previous case we got 15 meter per second square. The change was in what? The change was in u, the initial velocity. Clear? So as I told you already, the steps are understand the question and write down the given information, then find out what to find, and third, select the proper equation. We also discussed about how to select the proper equation. Okay? So thank you everyone. We are already out of time. The rest will continue. Okay? Thank you. Thanks a lot.
Hello students, welcome back to Chemistry at Gravity Cloud. Let's continue journey of chapter of Is Matter Pure. In the last class we had gone through few of the concept problems, right, where we had discussed how we can find the different problems and how we can solve them by using the concentration methods. Also we had gone through the two important separation techniques using which we can separate one component from other. right? First technique was sublimation and second technique was evaporation. Let's continue the same topic. Let's continue the same way how we can separate one component of mixture from the other. Now before starting it, I would like to ask you one thing, that have you seen the black ink? Have you seen the ink which is black in color? Right? Now in the schools also, I don't know it happens during your times or not, but during our times we used to use the black ink pen. We used to use the black ink pen, right? So what do? We used to have a pen and we have to fill the ink in that pen, and we usually use black ink, or we can say red ink and blue ink. Important thing is, this is not important that why do we use the pen. The important thing is that if this color is black, if this ink is black in color, does this ink contains more than one color, or it is purely black only? Now you must be saying that, sir, if the ink color is black, then obviously it is black. But what I am asking from you is that if this ink is black in color, can we get black color by combination of 2-3 colors? Yes, that is what I am asking. That suppose, for example, if I combine red with yellow, if I combine red color with yellow color, I will get different color. I will get a different color, right? So if I have the black color, if I combine the red color with yellow color and I combine these two colors with blue color, right, I will get the black color. How it happens? Simple. See, important thing is the black color is called secondary color. Black color is called secondary color, right? How do we get the black color? We can get the black color if we mix. We get the black color if we mix blue plus yellow and red. If you mix these three colors, that is blue color, yellow color and red color, mixing of these three colors give us the black color, right? Even if you can see here, if I use the red color, yellow color and blue color, you mix it, you will ultimately get the black color, right? That means if you want to get the black color, do one thing, take a red ink, mix it with the yellow ink, right? Take red ink, mix it with the yellow ink and mix it with the blue ink. In short, take 1 spoon of yellow ink, take 1 spoon of blue ink, take 1 spoon of red ink and mix them together. You will see that upon mixing them, you will get the black ink. You will get the ink which is black in color, right? That is the important thing. Now important thing is, once you get the black ink, how can we separate the different colors? Suppose we have this black ink in our home, right? And you want to separate the blue color, yellow color and red color from this ink, from the black color ink. How will you do it? That method to separate the components, or we can say the colored components, from one and each other is called chromatography. It is called chromatography. So basically chromatography is that method which we basically use to separate one color from the other, right? So if you go by definition of chromatography, what is it? Chromatography is the, or we can say chromatography is what? It is the laboratory method. It is the laboratory technique for the separation of mixture of colors into individual components. Simple. This is the definition of chromatography. That's a laboratory technique by which we can separate the mixture of colors into its components, right? So if you have to separate black, if you have to separate blue, yellow and pink color or red color from the black color, we can do the chromatography of black color. Simple. And because of this chromatography method, we can easily separate the colored pigments in plants and flowers. Easily. Right? Now we know rose is red in color, right? And jasmine is also having a color. So how do we separate the colors of these plants? How? That is important to understand, right? Like with lotus has lightish pink color. How we separate that color from this plant? For that thing, we have the chromatography method. Simple. Now, important thing is, what is the technique of chromatography? Or how we use or how we apply this technique in separation of colors from each other. So we'll do one thing. Let's suppose, take this paper. Let's do one thing. Take a paper, right? Take a paper like this and do one thing. Create a line over the paper. Take one paper, simple paper, and create a line. Mark the line over the paper. Now do one thing. Take the black ink. Take the black ink and put a drop of the ink over the line like this. Right? We have the paper. I take the strip of paper. This is my strip of paper. Right? I put one drop of ink, black ink, over the line. I take the paper. I mark one line over the paper by using the pen and pencil. Simple. Right? Then put the ink drop over the paper. Now do one thing. Take this paper and hang it in the beaker. Right? What I'm doing here, I have hang the paper. Just a second. Yes, hang the paper in the beaker. Hang the paper in the beaker, right? Like this. But to ensure that the dot is just above the water. Let's say this is my water. This blue color is water. Right? This is my water. So I have hung the paper in the water in such a way that this line, that this dark color line is just above the level of water. Or I can say this dot or black color ink dot, it should not touch the water. Right? It should be at such height that it should not touch the water. Understood? You have to do this thing. Place the paper inside the water beaker in such a way that this line, this black line, it should be very close to the level of water, but it should not touch it. This dot should be close to the level of water, but it should not touch it. Right? I can say that the ink dot should not touch water. Should not touch water. Simple. Right? This ink dot should not touch water. You will see what will happen, that with time, as the time will pass, you will see that we know the black color, as we know that the black color is made up of three different colors: red, yellow and blue. Right? The black color is made up of red, yellow and blue. You will see as the time passes, you will see that what will happen. This solvent, as I told you, this solvent is water. This water, it will go up the paper. Right? This water, it will go up the paper because water will absorb the paper. This paper strip, it will absorb the water. Right? When it is absorbing the water, it will go up. When the water will reach here, what it will do, it will take the components of ink. It will take the components of ink and it will take those components along with it up the paper. Right? As I see that water is moving up the paper like this. Right? The water is moving up in this direction. Or we can say the water is getting absorbed by the paper strip and it is moving in this direction. And all the components of ink, they will separate like this. All the components of ink, they will separate along the upward direction. Right? So suppose this is a kind of ink. This is one ink. Right? And I have put the dot. I placed it into the beaker. After some time you will see that this ink 54 degrees Celsius or 54.5. Right? So there is a great difference. There is almost the difference of 46 degrees Celsius. So 46 degrees Celsius is a great difference in the boiling point temperature. Right? In that case, we can easily use the distillation. But what will happen if the difference in the boiling point, right, I will say delta T is what? Difference in the temperature, boiling temperature is less than 20 degrees Celsius. what will happen if the delta T is less than 20 degrees Celsius, or we can say the difference in the boiling point of two liquids is less than 20. In that case, how the distillation will occur, or is the distillation will occur or something else will occur? We have to understand that thing, right? So do one thing, we'll continue from this topic onwards in the next class, right? And I hope you understood each and every point today in this class. So meet me in the next session and we'll continue from this topic onwards. That's all for today. Thank you.